So this week is all about molds, and mold making. Julia is by far the pro for this, and so I'm gonna let her talk as much as she possibly wants, and I'll just click the slides. And ultimately, the only reason why we put this one first, I put this one first originally in the lineup, is because you have to make a mold before you can cast something. That's it. And so they sort of like intermingle these 2 weeks for sure, but we've got things to talk about, stuff to do. I molded my own thumb for those who are at home. There it is out of plaster. Here's the mold and the cast. We'll take a look at these a little later on. But that's it. Time to get started.
All right.
So
moving everybody. Okay.
We've got, moving everybody out of the way is really helpful so that you can see what you're doing. But the big thing here is that we're going to go through these sort of 9 topics. So we're going to just define molding and casting, talk about pliable and rigid molds, chemicals and trapped gases, cure inhibitors, not cure your inhibitions is a fun play on words, release agents, open face and flat molds, 2-part molds, multi-part injection molding, and vacuum forming, all of which fit into this camp. Right now, Lior was doing a project where he's molding things and he's using a lot of vacuum forming to get that ready. So if you've seen Lior in the space, yeah, it's really cool. He's doing like a fun, he's trying. So these are what we're going to go into. And it's worth saying that injection molded plastic is like basically most of the things that you touch throughout the day, which is pretty sad. But that's probably true for many people, between your cell phone or your laptop or lots of other things that you might hold on to, the car steering wheel. A lot of that is injection molded plastic. And so that fits into this camp, and we'll talk a little bit about what those molds look like. But Julia, molding and casting is best learned hands-on. Your experience with this is?
Yes. The thing with molding and casting in general is that it's very difficult to get your head around it when you're starting out, because everything's kind of upside down and backwards, because in order to make a positive, you first have to start with a negative and vice versa. And so the important thing to remember is you start simple and then get more complex. Do not start with complicated projects, because there are so many variables that are unique to every single every single object, that you're trying to reproduce, and every single project, that your ability to have like a good successful experience is helped immensely by kind of understanding basic principles gradually over time, rather than just jumping into something where you don't know what you don't know yet. And I'm going to kind of go, like, if anyone wants elaboration on anything, you can feel free to ask, but I'm going to start with sort of like the basic level, like simple things, and touch on the more complicated stuff, but I'm not going to go into it too deeply, because your eyes will roll back into your head and it'll get overwhelming. And, but the reality of it is, if you've ever made muffins or cupcakes, you've used a mold. It's that simple in the abstract. And so that's where we're going to kind of start. So any questions or anything so far? Okay.
All right. So first up, let's define what this is, if we can.
All right. So the mold, like it's extremely important to kind of learn how to name things, especially when you're asking for help. So at the very base level, a mold is a form used to make something. Typically that means it is a negative, meaning it's a hole in the shape of something that is then filled with something else. The casting, which can be and molding and casting can be verbs or nouns. So either way, you're fine. The casting, though, or the cast, is the thing that comes out of the mold. So frequently people will come to me and say, I want to, get a molding like this thing, and they'll show me something that's a cast, and like it's a small thing, but it can get a little confusing after a certain point. And so if you guys get confused with the terminology, just ask me, you know, be like, hey, I don't know what to call this thing. Because it'll make it a little easier, like as you're kind of gradually learning the concepts. And so here you see a couple of really good examples of different things in everyday life. There's the muffin tin. But if you look at the muffin tin and then you look over on the right to that Bronze Age spear tip mold, which is an awesome thing that Corey found.
Yeah.
It's the same principle. Like, I mean, you know, it's a void that was filled with something else to make an object. In this case, it was metal. But on the top here, this lovely ubiquitous cherry is a much more complicated type of mold that you can absolutely learn how to make after you've tried a couple more simple ones first. And the chocolate mold, very similar to your muffins in that it's a simple open face, like it's a one-sided mold basically, where you just fill it and then you don't have to worry about it. And then the one in the center is a two-part mold of a relatively simple shape, like very straightforward. And so things have different levels of complexity, and they require different levels of complexity in the mold in order to make a cast or a duplication of something. So and it's molds, a lot of times people will say, with 3D prints, why wouldn't I just print a bunch of them rather than making a mold? And truly, sometimes that's the right answer. But molds have a lot of, they have a lot of utility in certain scenarios where you want to reproduce a lot of copies of something very quickly, or you need to change your prototype into a material that you can't do by 3D printing it directly. And that allows you a certain flexibility that opens up a whole world of possibilities, especially if you just like making things. But I will say this right now before we get started: molds are not fast. Like, it is generally not like the go-to for certain things, because it requires prep and execution to make the mold. Then you can start casting, and you'll see more of what I mean. Like, there are certain things like Corey's thumb there that are an exception to the rule.
Yeah.
But you have to keep in mind that you have to put the time in to make the mold before you can start to use it, and that's frequently not a small endeavor, depending on what you're doing. So okay, then on to the next slide, I guess.
Yeah.
Pliable and rigid. Yeah. This is what I was thinking about with the muffin tin versus the chocolates, right? That the muffin, like, you can squish a muffin, but you cannot squish the chocolate. And so the chocolates need the silicone mold because the mold can peel away and the chocolate's rigid. But for the muffin, the mold is rigid and the muffin is the squishy part. They do, yeah, there are silicone muffin tins. Those feel like an oxymoron to me.
Yeah. Your good old Reese cup there is a nice example of something that's designed to demold easily based on its shape, so that it's not, you have this sort of this draft angle that allows it to release from a rigid mold in order, it could be slightly flexible, but it's the thing that you're casting in this case is made to come apart easily from the mold.
Yeah, and they use the paper as a release agent, even better in that molding game.
Yep.
So yeah, but this is huge, and something that you're always, it's like a cardinal rule you have to follow.
Yes. So with molding and casting, most of the time you are making a rigid cast in, say, like the copy of the thing. The cast you're making is going to be maybe plaster, maybe a resin, like a plastic of some sort. And then the mold will be a flexible rubber. So you bend the mold out of the way to get your part out. Sometimes it's the reverse, where you can use a rigid mold, but then the thing that you're casting, the cast itself has to be flexible enough to come out of the mold, unless you have a super perfectly engineered mold, which you see a lot with like with injection molding and stuff. Those things have to be like exactly perfect, because something that comes up in mold making is the idea of a mechanical lock, where the part, like the mold, comes around the part and does not allow it to release if there isn't the flexibility to get it out of the way in either of the parts. So it's an extremely important, very basic concept, and it's the thing that it's also known as undercuts. Okay, if you have an undercut, that's basically a mechanical lock. It's the thing that it can frequently trip people up a lot when they're first learning. So just, you know, keep it in mind.
And a few people should have experience with that from composites. If you had fabric that wrapped around the bottom of that plastic bowl, that was a mechanical lock. So it would hold it together and it would make it really hard to come apart. So
Yeah.
lots of people in the group have that experience.
Yep.
Oh, here's the more examples.
Yep. So this is the mold is squishy, cast is hard version. And you definitely need to, like here, the planning ahead part is extremely important, because you're always thinking about, how am I going to get this thing out of the mold? And one of the ways is by making sure your mold is flexible enough to move out of the way, you know, for you to be able to bend it to get the piece out. And the, let me see here. Another thing down at the bottom where you can see Corey's countertop, that mold is actually meant to be taken apart in the end. You unscrew the sides to get the cast out of it.
Yeah, that a countertop at a house that I had back in Cleveland that I cast out of concrete, and that mold is all it's all melamine, and so the concrete didn't stick to it, and I disassembled it afterwards. So not quite squishy, but in the same vein, like it has to be able to be removed.
It just needs to be able to move out of the way to not damage the cast as you're demolding, which is the term. You demold a cast, take it out of the cast once it is set to whatever its final properties are.
All right, next up, chemicals and trapped gases. This is where we get sciencey.
The bubble section. Okay. Starting out, when you look at the sheer amount of different options you have, it is immediately overwhelming. And I am going to show you how to read the very scary at first, but actually not that complicated spec sheets, so that you're able to choose the type of material you need. But the rule of thumb is to work backwards. You're like, what do I need this thing to do? And how am I going to end up making it? Like, how am I going to mold it? And then you're going to determine the properties you want, and then go and find the material that fulfills your needs, rather than saying, I'm using this material and then trying to work around it, because it might not be the right thing for your project. The important things to keep in mind are like the hardness or durability of the materials, their color and opacity. Like some, like resins, for instance, a lot of them will be like a white or an off-white or a clear. Pot time and set time are huge. And then mixing ratios, or just generally how difficult they are to mix. And there's a very good point here. There's sample kits for sale. Like we're looking at the Smooth On website here, where we have a lot of their products. But pretty much any mold making or casting product has the option of you getting like a small amount of it to test it out and see if it'll work for you. And I highly recommend that, like especially if you've got something large that you want to do, before you invest in, you know, a gallon or 5 gallons of something, get a little bit of it and see if it does what you think it's going to do. That is extremely important. And this is just a Smooth On website, which is where you'll see information on a lot of the stuff that we have at MakeHaven.
Yep.
So, yep.
And those kits can be helpful. The small kits can be helpful. I've done a lot of projects where that's enough too.
We have handy dandy reference materials. At MakeHaven, I have, through the magic of lamination, left you guys some nice little references where, let's see, we've got a wall pocket in between the tool wall and the casting table there that has the material sheets that has the specs on the materials, which I also nerdily have on my wall.
That's
And
great.
these basically, sorry. Oh, no, okay. It thinks it won't let me show you, sorry. And that has all of the pertinent information on a material. And then there are two other charts that I put up. One of them is the shore hardness scale. And shore hardness, there are two types. There's a shore A and a shore D. And that basically is just how squishy is it if it's a rubber, and how hard is it if it's like a plastic or a very, very hard rubber. And what that scale, that chart does is it shows you what a shore hardness means in something you're already familiar with, like it's like a gummy bear or a pencil eraser or the heel of your shoe, rather than, you know, shore 10A or something. You know, it takes a little while for you to get used to what those mean. And then the other one that is up on the wall in the center of the station near the gloves is the Centipoise scale, which is viscosity, which basically tells you how runny the material is. Is it closer to water, or is it more like molasses, or even thicker, you know? And it relates it to, you know, like these are like water, these are like oil, these are like ketchup. And that's one of the things that you need to kind of keep in mind also when you're working, because if you have something that needs to get into a lot of little detail, you want something with a lower viscosity that flows more like water so that it gets in and around everything. But if you need to slap something onto a vertical surface and have it not run off, you need something that's a much firmer consistency that's not going to, you know, just run down the wall. Here on the left, this is an online chart again at Smooth On, where it has the product name, and then all of the information that you need to decide which one you're going to get. And those things are going to be, first off, weight ratio or mix ratio by weight. There will also be a mix ratio by volume if that applies. There are many materials that require you to use a scale in order to mix them. And it can't be a, you know, just generic, not very accurate scale. It has to be an accurate gram scale like the one that we have. They are frequently, I use postal scales. That's what we've got at the casting station. But you have to be able to get the appropriate ratio, because like, for instance, if you look down at the Mold Max 60 there nearer to the bottom, it's 100 parts A to 3 parts B. That you can't eyeball that. Like, it's very, very tough. And then another thing that's very, very important is both pot life and cure time. The pot life of anything is how long you have to work with it before it is too cured for you to keep working. Meaning, like, your resin is hardening, your rubber is starting to lose the ability to run, and that varies widely, as you can see here. The pot life, we actually, at the very top there, you see Mold Max 10. That's what we have in the big barrel, and it's very, very forgiving, especially for newer people, because you have 45 minutes to work with it. So if there's any scrambling you have to do, or you forget something or whatever, it's really, really forgiving. If you look down to the bottom, the UMU 25, it gives you 15 minutes. So you can kind of bake in a little extra padding for yourself if you're kind of, you know, just starting out, or you're unsure about the process, and it lets you kind of not be rushed, which is a very, very important thing. You want to be prepared before you get started, because when you're rushed, you skip steps by accident, and you make mistakes. So I highly recommend choose things that have a longer pot life when you're just starting out. And then the second part that, I mean, it's not included in this, is cure time. That is how long before you can take the thing out of the mold, or before, if it's a rubber, before your mold is ready to be used. And that can range anywhere from 3 minutes to 48 hours, you know, depending. It's just another factor. On the chart, you're also going to have viscosity measured in Centepoise. And that's when you want to look at that chart saying, okay, is it like water? Is it like corn syrup? Is it like molasses? You know, to get an idea of like how it's going to behave and whether it makes sense for your application.
Can you spell that word Centipoise? I never did.
It's, can we spell Centipoise? I'm gonna try Googling it.
Centipoise.
Centipoise?
Yep.
Like that?
Yep.
Millipascal second. Yeah, it is a
There you
metric
go.
unit. Look at that.
Mm-hmm.
Oh, I need to put this on a sophomore chemistry test for sure. Yeah, but
so
but these are, it's totally that sort of properties game. It's really like why you're well into the chemistry realm when you're thinking about molding and casting, which is why those mix ratios matter, why all these properties come up in tables, and they are chemists who are making these things, right? So they're thinking about it like a chemist, and at some level so do we, right? So there's all these different details, and it's why to that, you know, to a chemist who's definitely going to have an analytical chemistry balance in their shop, 100 to 3, totally reasonable, but not to any like normal
yeah,
person.
if you're trying to do it in your kitchen, forget it. You know, like you have to prepare for that. There are you see that this is mixed ratio by weight. There are some that are by volume. The Umu series there, those are meant to be easy to mix. They're just 1-to-1. You can tell that by volume. Yeah. You can tell that, you know, part B is a little heavier than part A here, but the actual like physical, I'm using it right now, properties of it are made to be simple, at the expense of other properties. Like I'm not a huge fan of that stuff for a lot of things, but it's great for simple flat casts or flat molds. But the thing that I want you guys to just keep in mind is that if you have questions, you can always ask me. But the things that you're going to want to look for is how long do I have to work with it, meaning the pot life, and how long until it's done, which is the cure time.
Yep.
Then you're also looking at, you know, the mixed ratios and things like that, but you have everything that you need at MakeHaven.
Right. And so that brings us to this. You got to be real when you're actually, the pot time and cure time are the things that I look for first as much more of a newbie. Because I want to know how long do I have to screw this up before I can fix it.
And sometimes it's 2 minutes. Sometimes it's less than that. If you get certain types of plastics, for instance.
Yeah. But then once I have found something that I feel like is got enough pot time that I can work with it, and I'm not gonna lose things. The next thing is to start to really lean into my chemistry teacher experience and talk about stoichiometry. So ratios by weight or mass, ratio by volume. It's tough to wrap your head around these if you haven't for a while, but because the chemicals are really weird. Humans are really, it seems like humans are wired to think about everything as having the same density as water, because we have basically the same density of water, and we pick up a rock and say, oh, that's heavy, but really it's sort of like you can pick up a small rock and still think it's heavy because it's more dense than water. It's weird. You got to stop trusting your perceptions a little bit and instead lean into the math, which is why this gets strange. You have to really think about the weight mass that they give you, or if it's a mix by volume, you cannot trust your gut with these things. You've got to do the measuring to make sure that it goes well.
Yeah, the first time you mix plaster, it's just going to seem so bizarre. Like, the ratios, a trick that I do is when I'm measuring, because you're a good citizen, you will have put a nice piece of paper on the countertop that you were using at the casting station so that you don't get stuff everywhere on the counter, at least. And I take a marker and literally write on that paper my ratios as I'm calculating them, because the instant I'll do it and be like, okay, it's like 48 grams A to like 13 grams B, I'll say that out loud, and like a millisecond later, I will have forgotten it or gotten it wrong somehow. So if I write it down, it's right there and you can double check it. Do not say, I'm sure it's fine.
Yeah.
It's not. Write it down, have it, you know, and if you're not sure, check again, even if it means recalculating and remeasuring everything. Okay. But yeah, when you're looking at it, make sure just when it says mix ratio, check whether it's by weight or by volume.
Yep, it's super important, and the chemistry is under no obligation to be nice to you. So it can definitely, if you get the mix ratio wrong, it might never cure, it might be weird and sticky. There's a whole bunch of things that can happen. It's definitely a thing to be careful and conscious of the whole time. Yeah.
Then I have a tray that is forever sticky.
Yep. Yeah. Yeah, there's nothing you can do. It's just the way it is. Sometimes you can put another layer on top and like cover it up, but usually it just goes that way.
Yeah, fully mixing.
Yeah, fully mixing is the other one.
Yes, do not skimp on mixing. And the sort of like, you know, some people think it's overkill. I don't, especially when you're starting out. You have the two parts, you put them together and you mix them really, really well. Then you move them to a brand new clean container and mix them again. This is to ensure that you actually have a fully integrated mix, because once you start working with this stuff, you'll see how sticky it is and how much can actually just adhere to the sides of your mixing container, which means you have material that won't cure because it's stuck there, it's not mixing in. And that's a very simple way to make sure that you're avoiding that pitfall. Do not get precious over mixing cups and mixing sticks and things like that. It's a thing I see frequently where people are trying to, like, you know, reuse and salvage their yogurt containers or something, you know, like there's nothing that is more expensive than your time and the materials that you're doing there. So you need to let the yogurt container go. Like it's part of it. All right. Okay. So pot time or pot life, cure time, and exothermic reactions. The pot time or pot life is the time that you have to actually work with the material before it is too cured to continue, meaning before it stops flowing, essentially. And the longer you have, the more time you have to sort of, you know, get settled and do everything that you need to do. When you are also adding other things like vacuum degassing, which I can show you guys this week live, you have to kind of work that in as well. So just be cognizant of your entire process and what you need to ask of the material when it comes to pot life. The cure time, it's how long you have to wait until you actually can take the thing out of the mold. And that can vary. Exothermic reactions mean.
I'll take this one.
Yes, please.
We just did the thermochemistry test today with my sophomores. But it turns out that some chemical reactions, almost every chemical reaction, will either release or absorb energy into its chemical bonds. But for almost all of them, for molding and casting, you're making plastics or silicone or something like that. And usually what that means is that things are making connections. You start them in two separate ways and then you lock them together. And when you lock them together, the chemicals are much happier. And that's a personification for sure. The chemicals don't really have an opinion, but it means that they're in a lower energy state when they lock together. And so in that lower energy state, that energy that's been lowered has to go somewhere and it exits the chemicals as heat. And so these reactions will heat up. That means they're exothermic. And so they're going to get warm. And then another thing about chemical reactions is that usually the warmer they are, the faster they go. So when you have a chemical reaction like an epoxy that starts to set, or I've heard Julia say it'll kick, it means that it's starting to get warm and then it gets warmer. And because it's warmer, it starts going faster. And because it's going faster, it gets warmer. And so it just turns into a spiral really fast. And so it's a thing that you need to be conscious of. And usually, especially with epoxies that harden, you'll notice that they go from like totally normal room temperature to all of a sudden you feel it's warm and then all of a sudden it's hard. And then it happens really fast and it's a self-propagating system of it gets warm and then it goes. We did that urethane for you and you can like, you put your hand on it and it's warm. 2 minutes later and it's toasty.
Yeah.
Oh, you definitely can. There's some really cool stuff that you can do. And I have gotten in trouble before where like I had too big of a pot of epoxy left together in like the bottom of a bucket and it started smoking all of a sudden. Like you can get into problematic ways with this exothermic reaction stuff.
It can be pretty surprising how much things can heat up, and you want to be aware of that from a safety perspective. But also this is like the number one way that people waste materials, bar none. Aside from just general lack of preparation. When you take, if I were to take the same amount of, say, a resin, could be epoxy, but probably let's say urethane, because that will usually kick, meaning cure, much faster. If it is in a larger thermal mass, say a bucket, the exact same amount will cure dramatically faster in that bucket than if you spread the same amount out on a cookie sheet. So when you are working, managing those thermal masses because sometimes you do need a lot of something altogether, break it up into smaller amounts and you will extend your working time. The second part of this is, I do want to just say from a safety perspective, plaster heats up a lot. And the more there is, the more it, the hotter it gets. It is something that people have been making like life casts for millennia, really. And people get it into their heads that they can use plaster directly on the skin for some molds. You can burn yourself very badly by getting locked into plaster and then having it essentially bake you in place, and you have to be chipped out. So no matter, like, please take this away. You can never submerge a body part in plaster to make a mold, because not only are you going to get stuck, you're going to get burned. So I always want to add that, especially when people are just sort of experimenting, because plaster's cheap. You're like, I want to try this.
Yeah.
No. Don't do it.
It's super cheap and approachable other than this part of it. It's a sneaky thing that most people don't, you forget about, right? At some point, we probably all learned this and then we forgot about it. And we're just reminding you all.
Yeah. Just from a safety perspective, I remember a particular incident when I was in college that required the fire department coming and like chipping someone out of a bucket, like these things happen.
Cool.
So it's bad news. So yeah, I think that the things that you're going to run across usually with resins is there's two types you're most likely to use: urethane and epoxy. Urethane kicks much faster. It's like epoxy tends to cure at a very steady, even rate. Like it goes from being completely uncured to being fully cured at sort of an even ramp, whereas urethane is like, it's liquid, it's solid, like suddenly. And so the managing like the thermal mass and the exotherm that happens from that is your way to like have success with that material. So, okay, onward.
Yeah. Cool. Another chemistry teacher moment, that all liquids, so we teach and know about the states of matter: solids, liquids, gases. There's more than those three, but it turns out that those are interesting developments that are more complicated than what we would teach young kids. And so all liquids, like water, will evaporate over time, or you can speed it up by boiling it. But lots of those liquids want to turn into vapors, and they want to take up some amount of the atmosphere also. So like water, you have definitely experienced hot, muggy days, or like fog is very common here when there's lots of moisture and then it gets cold and it doesn't quite sit right in the atmosphere. Water vapor is really good at going up into our atmosphere. So that's really true. There's a lot of water in the air all the time, but all of the chemicals that there are, they all like to have just the right balance between their vapor state and their liquid state when you're at our air pressure. And some of them are much more happy to be a liquid. Some of them are much more happy to be a gas. And if you're close to that border, you're going to get evaporating to happen. And to not get too deep into the chemistry of it, most every liquid has gases sort of dissolved in it, and they want to come out at some point. And so there's essentially two ways that you can deal with that within molding and casting. First is the vacuum chamber, where you force them to come out by lowering the pressure. If there's a gas that kind of wants to be in a liquid, it kind of wants to come out, and you're worried about it, you can suck them out preemptively by using the vacuum chamber. So you release those gases from the liquid. Getting sort of sloppy with my chemistry language, but it helps to understand the narrative. So the vacuum chamber can pull those gases out early so they don't show up when you actually make your thing. You'll need to do that during the pot life of the chemical, though. So you're going to pull those out. And the other way that you can do it is you can apply pressure. And so you're not trying to remove them, you're just squishing the liquid so much that they're happy to live in their liquid state rather than coming out as a gas. And that means that there's always going to, maybe you always have some bubbles in some resin, but by raising the pressure, you can make it so that those bubbles don't evolve, or what's commonly said is that you collapse the bubbles back in on themselves. And so a pressure pot during the entire cure time, or during almost all the cure time, can collapse those bubbles, and then they never evolve that way. But if you have a big thing and you want to remove vapors from the resin itself and then maybe apply it to something that you can't fit into a pressure pot, you could use a vacuum chamber to try and remove those things that will be volatile organic compounds from the resin so that they don't come out mid-cure.
Yeah, and it's a very important point that Corey made. Bar none, pressure casting is the way to get tiny little detail. It's great. It forces the material into all those little nooks and crannies. When you are making a mold under pressure, meaning you have your mold set up, you pour the rubber in, you put it in the pot, and you pressurize it. That material is curing while under pressure, which means all of those bubbles are squished. They're like in the solution. And if you imagine, say, like having a balloon, you know, in a bucket of concrete or something, as the concrete sets, if you keep pressure on the balloon, when the concrete is rigid again, that balloon can't go anywhere. If halfway through, before the concrete or whatever it is, plaster, it doesn't matter, has set, when it's still soft, it's like partially cured, but not completely. If you let up with the pressure on that balloon, it's going to expand again. Then the rest of the setting process will happen. And so it'll deform the entire scenario. So when you are making a mold under pressure, the rubber has to stay pressurized for pretty much the entirety of the active cure time, because it will sort of allow the gases to sort of reinflate before the material has completely hardened, and that's going to result in distortion. You can't avoid it. The other thing that's important, if you're going to be making casts, meaning taking your nice mold and pouring your resin in there and then casting it, the entire thing under pressure to get that nice detail, that mold had to have been made under pressure. You cannot cast under pressure in a mold that was not made that way. If it was just made on the countertop, even if you vacuum degassed it, it will come out looking like a pickle, oddly, because every single little tiny itty bitty bubble that is trapped, even if you can't see it, will get filled with material because of the pressure of the casting process. So both of these ways are good for different things. If you have something that can fit in the pot, it's great. You'll get really good bubble-free detailed castings with no pockets of air or losing detail. If you have, say, something that won't fit in the pot, you can always vacuum degas it and you still get really great results. And I can show you guys on Thursday a couple of examples of different things made that way. You'll see there it's also another great method. So you typically don't need to do both, like some people do, but you really, like, if you're going to be pressure casting, you don't need to vacuum degas typically as well. So okay, that's all I got.
Yeah.
Yay.
All right, and we included this one because the cherry's back, but it's definitely, if everything we've done so far has been new, we wanted to say, just sort of like let your eyes glaze over for this, because these are details that are important if you're getting to be more advanced. If this is your first time and you're focused on these, you're sort of missing the mark. So
yeah, those beautiful little Rolos there, those were engineered to come out of a mold easily. It's great. They're tapered. They don't have any undercuts. It's perfect. All right.
yeah.
It's just like made for ease. The cherry, on the other hand, has a lot more going on. First of all, this is a two-part mold, meaning it has a flexible rubber layer that is actually on the surface of the casting. And then it has a rigid outer shell, which is also known, it's the mold shell or the mother mold, both of those are interchangeable, that helps the floppy rubber keep its shape during the casting process. And so the rubber fits into the mold shell. If you were to take that, just the rubber part out, it would just collapse. Like it won't hold its overall shape. So the rubber's for the detail, the mold shell is for the overall form. You'll see a couple of things. First of all, at the very top there, that is a sprue or a vent. It's a way for air to get out. And it's kind of like plumbing. You need like the water, in order for the water to go down, the air needs to be forced out. And then on the other side is the inlet or the pour spout. That's where you pour your material in. If you pour material into a mold cavity that has trapped air and the air doesn't have a way to exit, you basically just get a void. You get a big hole in your cast. That's why that is. And then the other thing is you can see those registration points on either half. One's a positive, one's a negative, those little nubs. Those are known as keys, usually, that's how they're referred. And they just make sure that the two halves line up properly. This is stuff that you'll get into if you start making certain types of two-part molds, which is not how we're going to start out. But we want to make you aware that it exists.
Yeah. So now cure your inhibitions.
Yeah.
Sounds great.
Okay, so this is brief but important. It's good. You need to know that it exists to know to look out for it. Some materials, most notably platinum cure silicone rubbers, have a reaction with certain materials, certain compounds that is known as inhibition. And what that essentially means is even if the rubber is mixed properly, the ratios are correct, if it comes into contact with certain materials, it just won't cure. It keeps the rubber from ever curing in that place. Not going to happen no matter what you do. And so typically the main thing that has always sort of plagued sculptors was sulfur and platinum silicone, because sulfurs were in certain types of modeling clays, and more often than not, that is where you're going to run into the problem. So if you are making a mold from a clay original, if it's like an oil blade, like a plastilina type, like oil-based clay, you really need to know what that clay is, or you need to do a test first, because it's going to rule out certain rubbers completely. And then there are certain types of silicone rubbers that are used for body casting that can react with like aloe vera and certain other things. And the basic rule is, if a material has a problem with inhibition with certain materials, like it's gonna say that, like in, you know, it's gonna have like a warning on it, and you need to read through the material to make sure that your, you know, your pattern, your original that you're trying to make a mold of is not going to cause a problem, because basically what that means is that you just have goo that you have to clean off of your original. And then you have to do the whole process again with a different rubber or something. It's very sad. It's a bad day when this stuff happens. So just look for it. And if you ever have questions, just call the supplier and ask them. They'll tell you. Like, that's something that people feel weird about. I bother the smooth on people constantly. It's like, this is what I'm trying to do. Is there going to be a problem? And they'll let you know. So yeah, that's all there is to that.
Yeah, in my brain, I'm thinking about it from a chemistry perspective, and the sulfur is actually pretty close cousins to oxygen chemically in a lot of ways. And so the two, I would assume that these silicone setups are probably trying to get a hold of oxygen atoms in order to set and stabilize, like they're oxidizing over time. And if sulfur is there, it's even better at making that connection than the oxygen. So that's why it'll block the oxygen from getting in there.
Sticky goo.
Yeah, and then you're just left with this that isn't what you want.
Exactly.
We can go way deeper into the chemistry of that, but that's not the point. So we'll
anyway, I
keep
just
moving.
want you to know that it's a thing that exists.
It's a thing.
Mhm.
Yep. And then release agents next up.
Okay. So when you're molding and casting, stuff sticks to other stuff. Just count on it. Things stick. Most of the time you don't want them to. So release agents are used to keep one thing from sticking to the other one. And that can, most of the time, that's going to be, you don't want your mold sticking to your cast because you want to get the thing out. And sometimes while you're making the mold, you don't want one part of the mold sticking to the next part you make because you need it to come apart in a certain way that you've engineered up to that point. Super annoying when you when they just sort of fuse back together, because silicone specifically, and a lot of others as well, but silicone will bond to almost nothing, but it will bond to itself. So if you have this perfect 2-part mold that you've set up and you've done one half of it, and you forget to put a release agent on the edge of that beautiful half that you just made, and then you do the second half, it's just going to stick to itself and create just a solid piece that you're going to have to cut open, and it's no fun. So always check that you have used mold release. Just when you're casting, when you're mold making, say to yourself, did I release this? Because 99% of the time you need to do that. Now, release agents can be like one of the most, like going back to the baking analogy, which is great, because one of the good examples is, you're making muffins or cupcakes. You got to use something to keep it from sticking into that pan. So you can use oil or butter, spray, you can use paper cups, whatever. All of those things are releases. Alternately, if you're making bread on the counter, what do you use to keep the dough from sticking to the counter? You'd use flour, right? Yep. So powders can also be release agents. And from a practical standpoint, in casting, you'll sometimes use talcum powder to aid with the demolding, but what will also come up accidentally is dust. If you are making a mold or a cast and there's a scenario where you're doing multiple layers of something, like some molds are brushed on where you have to brush on a layer, let it cure, and then brush on the second layer. If you say, leave it to cure in a room that's dusty and it gets a coat of dust, when you go to apply that second layer, it's going to keep it from sticking to itself when you want it to. That can be really irritating because then the thing starts delaminating when you go to use it. When you are, this is one thing about in a wood shop, don't spray liquid release agents in a wood shop or near people's projects, because just a little bit of a release like this one, which is ease release, it's a very common, really good, like dedicated mold making thing. Even a little spray of that can completely ruin somebody's ability to put a nice finish on, like, say, their woodworking project. So just be cognizant of that, because you can do it to yourself as well.
The other thing that's worth saying is that this place is a dust making machine.
It's insane.
And so just be if you're gonna leave a thing and want to come back to it, cover it. Cover it with paper, cover it with something, cover it with anything, so that it's not left open. Because with the wood shop and then the metal shop, there's just dust everywhere all the time.
Yeah, we just got ceramics, like we just live in a dust vortex. So release agents, basically, they grease up your piece usually just to get the cast out of the mold without breaking the cast, without breaking the mold, making it easier. Lots of different reasons. The other thing about them is that they dramatically, like with silicones, for instance, they don't necessarily stick to a lot of stuff. Like you could theoretically cast in the silicone molds without a release agent for a lot of materials. It'll still give up, but the release agent will make it easier, and it reduces the stress on the mold, because molds do wear out. I mean, they will, they tear, over time, depending on how many pulls you need to get from them. You can dramatically increase the library life of your molds, which is what, basically its usable life is called, by using the right agents. And, it can be kind of anything that works. Like I'm a big fan of just good old petroleum jelly, like Vaseline will work for almost everything. Baby powder is great for a powder one. And then certain things like plaster molds, if you're doing waste molds, which is a different type I can talk about later, you use Murphy's oil soap because it actually soaks into plaster and leaves a nice film on the surface that keeps things from sticking. So lots and lots of different things out there. You want to double check with your material to make sure that the release agent that you want to use will work with it. Again, you just read the bulletin or ask. So onward.
Cool. All right. Open face molds, the flat molds. These are this is where we should spend our time this week.
Yes.
And I've got some examples. Let me talk about the examples down the left, if that's all right. This is, again, those countertops. You can do a lot in an open face mold. So this was the concrete countertop that I poured a couple of years ago. I did a CAD model for what size I needed over the cabinets that I had. I made a cutout for the sink and then built the borders out of melamine and cut a foam filler for where the sink would be. And then I laid it out here. I had to put a release agent of a Minwax oil or Minwax across the surface so that it would stick even less to the melamine. And then I laid down a layer of cement concrete. And concrete is a weird material. It takes very little water in order to mix it by its recommendations. If you're mixing concrete, you're probably going to think it's not runny enough. And my instinct has always been to add more water, and that's what I did in this scenario. However, that is not the right answer. just so that you know, there's a magical material called plasticizer. It's a powder. It looks a little bit like powdered mustard seed. And you mix it in, and all of a sudden it goes from like peanut butter consistency to just soup. And it's really bizarre that like a spoonful of this powder will turn cement that way, turn concrete that way, but it just does. And that's absolutely what I should have done for this counter. Instead, I made my first layer a little watery. And I eventually coated it in epoxy, so it's fine. But it was a layer of that, and then I put in some material to make it a little bit more rigid. So it was a composite material. There's some rebar and some metal screen, and I put in some fiberglass.
Would withstand a nuclear blast. Looking at
Yeah, it really could withstand a lot. Well, it had really thin sections on either side of the sink, so I had to be careful to make sure in those areas it was really strong. But it totally could withstand a lot, and it was about 2 inches thick. It worked great. I really loved it as a counter. And then I moved, so that's not my counter anymore.
So you flip it.
I did. And so I bought pizza and beer and had friends come over, and the big one weighed about 800 pounds. And so we had 8 people lifting little corners. Maybe it was 800 pounds collectively for the whole kitchen. I think that was true. I think the big one was more like 400 pounds. And so it was one 400-pound piece with about 8 people there to lift and flip. And it was a lot, but we got it. We moved it from a garage to a porch. And then eventually I got it set onto the cabinets. And here it is like dead level with a laser across it. So you can it's very good to do. Concrete countertops are great. They're very cheap. Like the countertops in that kitchen, I think collectively maybe cost me $50 worth of materials.
Yeah, but you made it yourself.
And I made it myself. And so that was a lot of time and energy and planning. But it was, I mean, versus a marble countertop. And it's not the same. I get that. But the price point is so much less. And it never cracked, never had a problem. It was very buttery smooth. Yeah.
And it's your own bomb shelter.
Yeah, and I could definitely hide under the sink and be totally fine. Yeah. And then the other molds, the candy ones.
Yep. And we've got some examples. I'll show you guys this week a fine art molds. I do reliefs, which are just flat wall hung sculptures, and that's the go-to. Anytime where the back of the thing doesn't matter and you're just filling it up to the top and calling it good, one piece mold all the way. It's terrific. We have some that are like for making coasters, things like that. You can make ornaments, you can do all sorts of stuff, and you can make a flat part that you then heat up and curve, because that's a cool feature of resins. When you heat them, they become plastic again, and you can, to some degree, still work with them. So if you wanted something to have a radius curve, you can make it flat and then use that property. So lots and lots of things that you can do just with this starter type of mold.
Yep, that's a great mold. This is what I did yesterday. So if you're in the room, you're going to be able to see the mold and the cast. So this is my thumb. There were definitely some air pockets, but this is a nice open face mold with exactly my thumb right there. And we still have the alginate all intact and the plaster thumb, but it's great. And this was, I mean, all together, it was maybe 20 minutes of mixing and making the alginate, and then another 20 minutes for, maybe 20 minutes for the thumb.
Yeah, the alginate that you see there, that's the same stuff they use to take for dental impressions. It is literally made of algae. So it is a go-to for life casting of any kind or body casting. And as you can see, it gets all the detail. It gets your fingerprint. It gets like every little thing. And it's relatively inexpensive. The catch being it's largely water. And so the mold itself immediately starts kind of drying out and shrinking, and frequently, and it is kind of delicate. So you see this form, it's a very simple no undercut. Like there's really not a lot to catch. But if you were doing something like this that has like a, you know, catch, like a hole through the middle and like different undercuts, you would have to destroy the alginate molds in order to get the casting out. And that's frequently how it's done, where you see people doing hand castings and things like that. But it's fast, cheap, and it's easy. So it's a really cool way to do a very, very detailed cast. And I think that was Hydrocal we used, which is a very dense, hard gypsum plaster.
Yeah, and this is, I mean, this would be a great way. We're thinking about Thursday or Sunday doing a group event for molding casting deals. Alginate would be a great option. We're still like musing those things out a bit, but
Why is
this
one
is
of them pink? What's up with the? Did you paint that, or did you add?
no, I don't. I think that was just a color correction on my phone.
Oh, okay.
That it like assumed it was really a thumb, and then I don't know why, but whatever.
And that's the color it chose.
That's the color picked. Whatever. 2-part molds.
All right, so
This is circling back a lot.
beloved cherry, it's back.
Mm-hmm.
So you can see handily circled in blue, all the keys there. Sometimes it is worth noting that when you do a mold, this thing is basically sliced just whoop down the middle, very straight. So those keys are important because it could easily slide back and forth. Frequently, if you have even like any kind of organic shape, you know, like this to a mold, it's going to self-key. So you don't need as much of this. And in fact, they can kind of like make it harder to get apart. But the part where the two molds come together, mold halves come together, there's going to be a seam line. That's just kind of part of it. If you don't get one, then you should note the date and time and remember it fondly, because it may be the only time it doesn't happen to you. And frequently you'll also get something called flashing, where a bit there'll be like kind of this little thin, like a thin little strip of material that projects out from that seam that you'll have to trim off. It's not unusual by any stretch. And then we got the sprue, which we already went over. And every mold has its limit. You can only challenge them so far, depending on what it's made of. And you got to keep that in mind. If you have large overhangs or undercuts or things like, or pass-throughs, sometimes you have to build up layers of rubber to get past that before you can make the mold shell when you're doing this kind of mold, because then it'll still lock even though there is that flexible surface there. And this is just going to depend on your design, and sometimes you have to just make another part to your mold to get it off. That's how it goes.
Yep. Okay, and then multi-part molds and injection molding. Injection molding is something that's fascinating. We have an injection molding machine in the metal shop. And if you have met the member Alex Murdoch, he's great. And he's making injection molded recycled plastic phone, not quite pop sockets. But that's the most common thing that people know the name of. It's really cool. Lots of the world is made through injection molded plastic because it's so quick and easy. This is where there's some exceptions about, you can have a hard object and a hard mold, but in order to make an injection molded plastic mold, you've got to really do a lot. This engineering,
a lot of engineering. Oh my God.
Like to make an injection molded, you can, if you design some magical product and you need to injection mold a part, to make that mold might cost you $10,000 to $100,000. And so that was the big, early in the pandemic, people were making their own face shields on laser cutters and different tools inside of maker spaces like here. And that was mostly because the tooling hadn't been made yet to mass produce them at speed. And once that was made, you can produce things super fast and many, many copies. Like Lego bricks come out in unbelievable speeds, but it costs so much money to make the mold and set up the tooling and do all of that.
Yeah, because you can't have any part where it mechanically locks in any
Yeah.
direction. And when you're dealing with all three axes, that's very, very hard to do. So this is a great
This-
video, by the way. You guys should watch it.
So I'm gonna. Oh, good. It's muted. This guy talks. He has his channel in general is good. He's got these great animations and like shows off all this stuff. It's really cool. He goes through the details. I want to try and find the exact graphic. Here's vents. You can see he's doing all sorts of stuff. And here's the animation coming up. He just talks.
He's so
What an
earnest, though.
He is. He means well. But there's like two sides, a two-part mold, and then there's ejector pins. It's a very complicated setup to do this really, really well, where you could do like this looks to me like a keyboard keycap, and that you could do it in like a fractional second. You're injecting hot plastic, and by the time the back comes off, it's already cooled, and then you pop it off so that you can just make them in mass. Is exactly what that is. But
Yeah, it's bonkers, but so cool.
it is.
And I believe, our tough resin for the Formlabs 3D printer can be used for injection molding. So you can make your own molds to a point with a 3D printing process rather than a machining process.
Yeah.
To
But
a
you could
point.
definitely do, but like the Tormach CNC, you can machine aluminum. You could totally make an aluminum mold and then injection mold recycled plastic here. You can make your own injection mold or recycled plastic parts if you felt like it. It's very possible. That's what Alex is doing basically.
What's he trying to make with? Oh,
He's trying to make little things to put on the back of your phone so you don't drop it. Yeah. It's, they're nice.
He's got
I should buy them. Yeah. He's got a what?
I think he has a patent, doesn't he?
I'm not sure. Pat, I would love to ask him follow-up questions because patents are hard. They're tricky, and I'd like to know how he's pulling it off. I assume he's got a provisional patent, if anything. But
I might be
yeah.
wrong on that, but yeah.
No, he might. He totally might. But it's a cool thing to explore here, for sure. So, don't play the little guy talking. Okay. And our last bonus, vacuum forming, is a good one to add in. Vacuum form shapes are great. These are I wish that I had vacuum degassing available when I made these. These are little silicone rubber stoppers for my robot bartender because I need tubing to go into the bottles of liquor and I didn't want to have them just be open. So these are plugs that will pass through the silicone tubing, and I made the shape that I wanted them to be on a 3D printer, and then I vacuum formed over that, and that vacuum formed plastic is the mold for the actual plugs that I was going to make. So it's back to that positive, negative, positive game that you really need to think about when you're molding. But
And
basically,
it is worth noting that this method is called gang molding, where you
yeah.
are making many copies of the same thing all at once. So instead of casting one at a time, you're casting 5 at a time.
Yeah.
And what a lot of people have traditionally done is they'll do their single prototype, make a mold, copy it a bunch of times, and then make another mold that's the gang mold for it. And you can, immediately double, quadruple, quintuple your productivity because the most expensive thing is always going to be your time. Well, maybe not always, but frequently it's your time. And so being able to speed up that process is amazing and really easy to do in a lot of respects. Like for something like this, it's perfect.
Yeah, this worked great.
Yeah.
I was able to crank out a bunch. I just did 2 batches from that gang mold and I had plenty for what I needed.
Yeah.
So
there's one thing that did occur to me that I just want to mention as a general concept before we wrap up. When you're making a mold and casting, you're always going to be sort of like, it's very time intensive and it's labor intensive. You're going to want to sort of make it as efficient as possible. And I'm not going to say cut corners necessarily, though that sometimes does come in. You have to remember that when you're making your mold, doing the thing that makes the mold easier, but makes it more difficult to cast or create something that you have to clean up on every single cast. That one thing, that artifact in your mold is going to propagate through every single cast, every single time you do it. And that adds up with labor. So if you are making a lot of copies of something, take the time to make your mold clean, even if it takes you a little extra time to do it, because you will thank yourself later when you don't have to like hand carve and sand every single cast that comes out of it. That's another frequent mistake that people make when they're starting out, especially when they start doing things more complicated. Saying like, I'll clean it up after it's done is not advisable most of the time. So anyway, moving on.
Yeah, no, but that's a huge point. Like the vacuum forming is great, and it's important that we include it because it's a fun way to make a mold. But also all of those seams that you see, they totally show up on the thing. So it's not like they're seam free. That was the thing that I had to deal with my silicone molds, and I don't mind because I'm not really looking at them, but it's totally a part of it. For these things, you have to be very careful and gradual in your curves. For like the hammer and mask and what stuff that's there, there's no, like, you really can't. But we had a member who was a facilitator last year named Bobby. We're all sad he moved away, but his job was to make sure that molds and forms and composites could all be made without wrinkles because he was building airplanes. So like it was important, like his entire job was how to make shapes and molds and composites that didn't have wrinkles and like make the best possible darts and planing and all of that. So it's possible. It's just like is at least one human's full-time job if you want to make complicated things.
Well, another, like the flip side of that though, if your mold is ugly, but it gets a nice cast, it doesn't matter. No one will ever know. So
Yeah.
like there's times to obsess over it and there's times to not. I
Sure.
know this is me saying this, but like, it, you know, sometimes you get like, you know, if that thing right there that has the wrinkles and everything produced a cast that was in fact very clean, fine. Who cares? Doesn't matter. As long as it gets the job done.
Yeah. One note though for vacuum forming itself, like this hammer is a terrible vacuum form candidate because it's got a big overhang.
Should have filled
Yeah,
in that.
should have filled it in.
hole.
This
Yeah.
egg looking thing has all those holes because if you didn't have those holes, it wouldn't be able to pull air through that egg shape and it wouldn't pull it all the way down. There's a whole host of different rules that go with vacuum forming, but basically you've got air sucking through the table and you needed to be able to suck through the table and maybe suck through your part also. So those are all things to take into account. But, you know, lots of fun to be had with vacuum forming. It's super quick, like a few minutes and it's done.
But frequently requires multiple attempts.
Yeah. So be ready for that if it's a thing that you're gonna try and make happen. My slides. Oh, that's just the end. There's no beyond that. So that's the end of our. That is the end of our slides for this. Any other last minute thoughts before we get on to when are you going to be around this week, Julia?
My typical hours are 6 to 9 on Thursdays, and I am probably available Sunday evening as well. So I just have to double check on that, but I could do both of those days.
And we were thinking, we had chatted about, but I suppose I never formally finalized it with you, but we'd like to have sort of a group mold making, even if it's just alginate together, so we can all sort of go through that experience. Would you be game to do that both of those times, Thursday and Sunday?
Yeah, sure.
Okay, because alginate is cheap. You can then make whatever you want out of that mold once you have it. So
thumbs, or we could make like rubber asparagus or something, you know, whatever. Like, it doesn't.
A weird silicone pickle, whatever, you know, make whatever you want. You can do whatever you want. I don't know. There's all sorts of crazy things that can be made, but it'd be fun to spend time on Thursday, Sunday, just sort of expecting that we're going to play with alginate and get ready to make fun things. If you have some object that's like probably no bigger than your own hand, and it could be your own hand that you want to cast, I think, is that a pretty good constraint to put on it for this first round?
Yeah, that's a simple size to deal with.
Well, the question, is the only material you can pour in there to cast the plaster?
Oh no, you can pour in all sorts of stuff. Kate did epoxy last year.
Just not urethane.
Yeah, urethane is a no. All the water is going to be a problem.
Yeah.
But
Urethane foams when it hits water. That's one of the two types of resins. So epoxy would be the way to go.
Could it be tinted epoxy so the epoxy is colored?
Oh yeah.
yeah,
Totally.
I think Kate's is silver colored.
Yeah, it's like sparkles.
Yeah.
It's
Yeah.
great.
So I was going to put LEDs in the cast of my thumb when I was going to do it out of epoxy. And then we switched to plaster. I might still work on rigging up that electric thing so that I can make a light up thumb later on in the
Well,
week.
we could make a rubber mold of your plaster thumb,
Oh,
and then you would be able to make many thumbs.
my plaster thumb isn't that good. There's bubbles in this particular alginate.
So let me ask you a question. So you make a mold and then you make a cast, and then maybe you want to make a mold of that cast, like you said, because what you want to put in there next is a different material. So what mold material can you use that could accept molten, say, pewter, metal?
There are high temperature rubbers.
Yep.
If you're doing pewter, that's a very low melt. I think actually, Corey, you managed to make one of those little video game things from that video game. I don't know.
I did. Last year I did Animal Crossing Fossils.
Animal Crossing.
Because it was the pandemic. And I used the Umu stuff that we have here because it was available.
Not Umu. It was
no.
It was the Mold Max 10. It's the one in the barrel.
That's right. It was the one in the barrel, and it worked okay, but it didn't love the temperature of the pewter, so it would frequently like give me real weird surfaces. I think if we're gonna do that, we should buy, and I would totally try to make another one of those with a proper surface because I still have the original. I would totally help with getting the high temperature pewter.
Actually, can you turn me around again so I can say? So there are specific jewelry making like high heat rubbers, but we also actually at MakeHaven have refractory cement where you can do a single use mold where you'll break it apart to get your part out. But frequently what you do is you make a rubber mold to make the copies of your disposable molds so that you can crank out a lot of them. Like that's very, very common. That's something that's actually done in ceramics as well, but we have that stuff on hand right now. Kate got some of it, so if you wanted to test it out. And I think you could go so far as to like pour a slab, carve into it, and do just an open face pour to see how it works for you as well. So.
Well, that's fun. Yeah. So that's a neat option. Other questions before we transition to show and tell? No? All right.
I'm going to show you.
Yeah. If you got show and tell, Julia, do it. You got
No, I was just going to say rats. I was going to show her there's this great picture of someone using one of those rubbers to pour a metal coin, and I was just trying to find that to show you, but
you can dig for that. While you're digging quickly, another thing that's worth announcing is JR and I just got VCarve 11 installed on all of those computers. So for those of you who installed it on your own computer and then couldn't bring it here because the version was out of date, should be solved. So it's the most up-to-date version that's on there now. So if you installed it last week, you got it. The one here is more up-to-date than the one at home. So and it's actually the same version, but it should then be fine. So that's totally an option now.
Can I show
Aha.
something?
Absolutely. Arvin is gonna show and tell first. I can point this at you.
Yeah, and I did find the thing whenever we got back around, so.
Hey y'all. This was my big project. It's not done yet, but
Is it CNC?
yeah, it's on the Gerber. So the mirror is gonna go here, which I have in the back, and I'm gonna sand it so it's smooth. And I was actually thinking about, I was gonna paint it, but now I'm like, oh, I wonder if like a resin would be cool on it too.
You
I do
could, you
like
can
a-
paint, you can actually paint with resin. You can tint it and paint it on
Mm,
as well, so.
Yeah, so I'm gonna do something for the surface, but yeah, MDF mirror situation. I don't know which way I'm gonna put it up, but
Yeah, it's beautiful.
Like affix the hanging things.
before I talked about this, probably either using the drill bit that creates the keyhole or
Yeah.
like affixing some type of like
Yeah, with a
hanging, yeah. So some type of hanging mechanism I'll put on the back.
The
Mhm.
slotting bit could work, but now, yeah, I'm wondering.
I was thinking maybe she should glue on a strip and then use that.
Oh, like a ledge type
It's like I
section?
have a bed made out of that stuff and I just took it apart and I'm discovering that all the screw holes are stripping.
Yeah, this stuff doesn't take to screws very well.
Mhm.
MDF is delightful, and then it's got no grain, so like you get all the detail. But that's a good point. Maybe like just a thin sheet of wood that you stick one of the like normal hangers onto.
Yeah, something, I'll figure that out then, but yeah, that's a
Or you
good
can use
idea.
epoxy, it soaks in.
I know.
Wait, what did, I'm
Say
sorry.
that again?
Yeah, say that one more time.
Epoxy can soak in, like if you have sort of like a fuzzy area or something where, you know, like how MDF gets kind of like it starts to disintegrate a little, like epoxy should actually like soak into it and bond and kind of strengthen an area. So that can be used like kind of as a spot treatment.
I have 1,000 follow-up questions for that.
It's actually great for plaster also. It soaks right into the pores and really strengthens it. That Ruby's thumbs up on the casting station, I did that for that cast and it worked really well. So anything porous, really.
Okay.
That's great. So you're saying the epoxy would go onto the MDF. That like my rule of thumb is never let it get wet because it wrecks itself. When you put resin in, it does the opposite of that. It just becomes a magical material that is perfect in all the ways.
I don't know that I would oversell it, but like I would basically probably because with something like this, you're basically dealing with what is the MDF equivalent of end grain, which is just sort of fuzzy exposed edges.
Sure, yeah.
And it should go in to some extent and soak in like the way water would, except without all the expansion. Like it doesn't just keep like it blowing up, you know. However, like all things, I would test it before committing, but it might be a viable option.
Yeah. No, that's
And
cool.
another thing you can do is use mechanical locking to your advantage. If you were to like drill little holes into the MDF at an angle, a reverse angle, and then fill them with epoxy, it would be creating an actual mechanical lock as well as adhering, which is nice for if you're trying to get something to like really hold on. Does that
Interesting.
make sense at all?
Yeah, sort of.
Yeah, I don't know.
We'll talk about it more. I'm definitely game to try that test with MDF. So
I mean, I can take a look at it and kind of like do it real time on Thursday if you want.
yeah.
in the back on my shelf, which is in the same aisle as to make the foundations class, but I'll be here Sunday.
Cool. And we'll grab a scrap piece of MDF and see what happens to just like a flat piece. And like, just to see how it behaves.
Yeah.
And did you?
I may be lying completely, but I feel like I've done this successfully at some point.
Cool, great.
Did you find out if you could load the bicarbonate?
Oh, no, I ended up, I mean, there is a way, there's like this program that you download. called-
Parallels, forget it, I don't.
Yeah, I forgot
Yeah.
I had my work computer, so I'm just using that, honestly. Thank you.
Yeah,
I'm so tired, I have to go.
you're all good. Have a good night.
Great, talk to you about,
Yeah,
drill bits to use for another thing.
yes, absolutely. Yep, no problem. All right. Anyone else wants to show and tell? I'm slowly rotating to Lisa. If you would like to show and tell, you're welcome to.
I mean, I didn't do anything this week that I did this week that's shown and tellable, but I just wanted to mention something I did, it was already last year. Let's see, can you see it?
Yeah. Here.
So it's a sand cast of a
Oh,
twig,
brilliant. Yeah.
this area here, and then, I soldered the other stuff onto it, but so it was sand casting, which was an interesting process.
Yeah, it's really cool. One of the oldest
So-
casting processes there is.
Yeah.
I mean, you've got these.
Oh, yeah, I
Yes.
wanna, someday, when it seems like it's appropriate, I wanna cast these, acorn cups.
Well,
They're
you could just dunk those in the refractory material, burn them out in the kiln, and then backfill it with metal. You'd have to
Yeah.
put sprues on them, but
I know, I need a sprue, yeah,
it's doable.
yeah, I'd like to, and then I'd play around with, the metal things. So I'd like to ultimately fill them with epoxy, like
Mhm.
resin, sorry. But, so, at whatever stage seems appropriate, maybe not this week, but whenever it seems like.
Yeah, I mean, because the thing with that is that cup does curve back around,
I
which
know,
means it is a mechanical lock on that interior void.
right,
So if you're casting, you have to kind of take that into account because it will not let go. Even if you use flexible rubber, you're going to pop that thing off of the stem
mhm.
pretty easily.
Is it too tiny to make a two-part mold out of it?
Well, I guess the question that I usually ask people is, how many do you need? And what are you making them out of?
Yeah, or I mean, I could make one and destroy it and then make another one for the next one and so
Mhm.
forth. I have like a bunch of them here.
Yeah, frequently the right answer is to make a bunch of single use rather than one repeat use mold.
That's fine.
Like with hand casting, you'll frequently just make 2 molds rather
Yeah.
than trying to make a reusable mold because it gets destroyed in the process and it's cheaper that way.
Mhm.
So that might be the right answer here, but not necessarily, especially if you need it to do something else, like, have some sort of other feature attached to it that the existing ones can't quite deliver.
I mean, I don't mind making a destroyable mold to begin with and see what I'm gonna do with these things,
Yeah. Well, the way to deal with that would be to say you have your cup,
Yeah,
and right now, I don't know if you can see the way it's that C shape.
yeah,
If you were to just make thicken the walls
yeah.
so that it no longer created that mechanical lock, then it would work.
Yeah, even if you just like stuffed a very tiny amount of clay, so it looked like the negative of a Rolo, right?
Yeah.
That chocolate candy.
Right.
So that it didn't ever overhang and become, because right now the top of the acorn is like a bubble that
Yep.
fits in there. And so we're talking very tiny amounts of clay, very, very small amounts around the outside edge so that it doesn't loop
Yeah.
around and make a C. So that it instead, like, you fill in this void, right?
So it's straight.
So it's straight walls rather than a curve.
And one of the enduring rules of sculpture is that if the edge is thin, the mind reads the entire thing as being thin.
Yeah,
That's
It doesn't
true.
have to be. That's just one of those features.
well, you'll explain it in person.
Yeah,
Yeah,
we'll take a
yeah.
look.
Bring a sacrificial acorn or two.
Plenty of them.
Yeah. All right. We've got people who, Norm, Renee, if you're around, have anything that you want to share, you're welcome to hop on, but also no pressure.
Yeah, I don't really have a whole lot to share, except that I'll just reflect in the fact that Corey said that one of the things about the big pieces was figuring out the logistics of stuff. And, you know, I was sort of feeling kind of defeated by the big pieces of plywood, and you know, I did know that I could get a badge on the panel saw, but then what do I do with all that stuff? And I know I could put it, you know, so I'll just share that my, you know, suboptimal way of doing it was to just get a succession of bigger and bigger duffel bags to carry stuff and then plan the cuts. I didn't try to do the Fusion 360 slicer that Corey uses, but I found that Inkscape, well, you know what, let me just share my screen because I took a couple of pictures so I can find them that'll maybe explain what I'm talking about if I can find it. You know what, I don't see it. It's not worth, forget it. It's not worth dealing with anyway. Fusion 360 lets me put the shapes and you move them around and it's freehand, but you fit them in, and I left a little room in between, and then I've got a jigsaw. So I cut out the jigsaw, the pieces more or less with a jigsaw. I could fit them in the duffel bags and then ran them into MakeHaven to work on on other machines to make them in final form. So that's just what I was reflecting on this week.
Yeah. Yeah. Make something big. You know, some of it's the Gerber, and the Gerber's got its own like quirks for sure. But it actually, like, working at size is really is really an effect to itself. So I totally get that that's something. And the panel saw is great. I was really, and she's already gone, but I was really inspired by Arvia's use of MDF because I've always dismissed it as like the material I don't actually want to put in my bathroom, but is cheaper because it's like when it gets wet, it gets trashed. But watching her make that perfect high fidelity shape on the Gerber, when I've seen Ruby make really cool art, but she loses to chip out from Baltic birch, makes me really re-question my despise of MDF, because it's a manufactured material enough where there's not a grain. And that adds a lot of value, especially because she's gonna like paint or epoxy or something over that stuff. I think it's going to come out really nicely, and it's a great material to work at scale. And the Baltic birch seems to go here pretty quickly, and or it's very expensive, but the MDF is very approachable for price. She bought a whole sheet for $30.
And the
And, like,
internet says that the epoxy will soak right into MDF. So
Great.
what you would have to do is just ensure that anywhere it will be pierced is pierced prior to the epoxy stage, so that you have a continuous skin for moisture purposes, and then you'd be able to finish it as normal.
Oh, that's
Wow.
so cool. Yeah, if that
Get
works.
yourself like those little threaded hardware,
Oh,
pound them in, and you're good to go.
yeah.
Do you think you have to epoxy it equally on both sides? Is there any issue of warping?
You would encase that thing like it's just you would want if you're going to put it in any kind of moisture rich environment, you completely coat it.
Well, maybe she's not putting it in her bathroom. Maybe it's just in the living room.
Yeah, hallway mirror I think would be fine.
Mm-hmm. I mean, it
Yeah.
exists all over the place, not in bathrooms. So
Yeah. Yeah. Yeah, all of those are totally reasonable. Yeah, that's really one of the ones that got me this week about like cool at scale process because it's a big mirror. Like it's huge, and what a fun way to have a nice effect. Yeah, the make something big is tricky because it feels like you should make something that's a giant monument, but that's big is all relative. So it doesn't matter. Big for you, big for your, big for the Chevy Cruze is very different from the Chevy Suburban. Chevy family. That's from the Midwest. We have strong opinions about this.
I did find that, like, if you guys want to see it, I did find the high heat rubber. If you want me to show you it.
Yeah, share your screen.
Okay, can you see it?
Yep,
Oh, is it a weird? It might be a weird format because I have this.
you're good. It's all tall, skinny.
Okay.
It doesn't matter.
So yeah, basically, the way this works is it's just a regular, a nice one-sided rubber mold. This stuff is Mold Max 60. The 60, the number after it is going to be its shore hardness, and the higher the number, the harder it is. The lower the number, the floppier it is. But this is just like a coin, and they're using baby powder, which is very nice for helping certain materials flow into all the detail, which is probably what they're using it for. This is critical. The problem with metals is the instant they cool down, they freeze. And so you're heating your mold before adding your molten metal. And they are melting down their whatever it is. I guess it must be pewter, tin, something. Pouring it in there. Look at it go. So cool. Ta-da! So that would be, and this one goes up to 560 degrees. And there's your end product. Pretty nifty. How do I stop sharing? Oh, okay, stop sharing. So yes, so that's pretty doable. And you'd only need like a little tester size to do a mold of that size.
Yeah, a tester of that Mold Max. I already forgot the name. Mold Max 60?
Yes.
Yes. Okay. A tester of that would be fun.
Totally. I mean, you could do multi-part molds. It's just that stuff is more like a really firm eraser rather than a like the very squishy Mold Max 10 that we currently have hanging out in great bulk quantity.
Yeah, that's like floppy and
it's wonderful for a lot of stuff.
Yeah,
but it's not made for this specifically.
Yeah. Yeah, I feel like I was always nervous to preheat it before I'd pour pewter in. Felt like, and it was totally just like me doing exactly what we said not to do. I feel like it won't work. I should read the stats and find out if it'll work. But I don't think it's rated for high temp. The Mold Max 10.
One thing it's funny with silicone. I actually microwave my molds before I cast in wax because it's the same problem. When the wax cools, it freezes. So if you have something with like spindly little fingers or something, if it cools down in the palm, then you get no fingers in your cast. And so I just throw them in the microwave. You can do that. You heat them up, and then it will be free flowing into all of the detail. It cools more slowly, obviously, but it's a great trick.
Yeah. So Julia is a never-ending well of magical molding and casting tricks, and would totally recommend that you just pick her brain all the time if you're doing anything molding or casting. So we're delighted to have her with us again for next week's casting stuff, and as often as she'll play along with us. So that we should
here to help.
That's great. You just keep committed to that. We're in. But
Somebody
it's
else run my dang slideshow. All right.
no, you're good. It's 8:50. We should probably call it for the night. But this has been delightful as always. And then Thursday and or Sunday we'll be in. You can come to both. We have plenty of this alginate stuff. Well, just offering. And so those are all fun things. We'll make all sorts of weird molds this week.
I plan to be making a hand base for my flower.
Oh, your trick that worked pretty well.
Yep, that was it was proof of concept.
Yeah, she's making a flower for a member who's having a rough time, and then a base to hold it that's a plaster hand.
And everyone
Yeah.
else can add their flowers to the bouquet.
Oh, yeah.
We'll give it up to them.
Yeah, that'll be very nice. I'm sure that they'll like it. So cool. All right. Have a good night.
everyone.
Have a good night, everybody. We'll see you this week.
Yes, and hit me up on Slack if you have any questions.
Yep. All right.
Bye.
Bye.